Hi, thanks. So I'm going to talk about how we might be able to automate the creation of CDISC ADaM datasets using the SDMX metadata standard. But before I get into the detail, let's take a step back and maybe look at what is the problem that we're trying to solve here. What I've got on screen is what I hope is recognizable as a 50,000 foot workflow of starting with the creation of a protocol where then we set up the EDC and data capture systems and are able to spit out SDTM. Statisticians start writing the SAP decomposed from the protocol. Once we've got a SAP, we'll start defining some shells and certainly probably before the shells are finished, we'll start programming ADaM datasets and then start programming the TFLs. So once we've got the TFLs programmed on the ADaM datasets, then we will do start blind reviews. And that's great because we've got loads of time to database lock, and then typically according to the PHUSE KPI, and I would kind of broadly agree with this, there's then about between 9 and 60 days from database lock to wrap everything up and produce a study package and a submission package. So that's great. So what's the problem? Well, I mean, the problem really is change, I guess. You know, we do the blind reviews, and now that I see the TFLs, and now that I see the data, the shells get updated. Because the shells have been updated, we need to update the ADaM programming. We need to then update the TFL programming and re-review. And then, of course, once all that, as all that's going on, along comes Protocol Amendment 1 of N, and Protocol Amendment means that maybe the CRF is updated, the SDTM is always being tinkered with, the SAPs, we get SAP updates, which then all flow into shell updates, and we're back to ADaM update and TFL. And so before we know where we are, that long period of time we had between to get the blind reviews done starts to crash into the DBL, and certainly programmers start to panic. So wouldn't it be wonderful if I could wave a magic wand and we did it differently? Wouldn't it be wonderful if we maybe set things up and started our workflow in the same way? So we define the protocol, we set up our EDC, we can spit out the SDTM, we define the SAP, and define the shells. But now in this new world, we define the shells in a different way, which means that we can press a button and go straight from the shells to the blind reviews. What happens? Wait, where's the ADaM and the TFL programming? Well, at the moment, we'll come to that, but we're going to do that after database lock. So if we did something like this, what would that mean? Well, it means A, we would have a lot more time to do the blind reviews, and that could possibly only be good for quality. It also means that we contain some of the change that percolates back into the workflow. So we update the shells, well, that's fine, we just press the button again and regenerate the TFLs. And likewise, there's a much shorter chain of change coming from protocol amendments. It does mean, however, that we would then, in this scenario, have a relatively short amount of time to do the ADaM and the TFL programming. So how's that going to work? So let's have a look at this. This is the data flow. This is the source documentation that we currently work with, and I think that we would and always will work with. So we start with the protocol, which begats the SAP, which begats a DAP, which may be slightly less widely used term, data analysis plan, which I'm really just using to say this is the further decomposition of definitions from the SAP, which CRF page are we talking about for that particular analysis and that kind of thing. So the detailed definitions and of course the table shells, I'm saying are part of the DAP. Now, today, typically, all of this will be created in Microsoft Word, maybe Excel occasionally in places, but effectively using tools for human readable documentation. And what we're really looking at is making that move. At very least, the DAP doesn't get created as a Word document, it gets created using tools that allow us to write it in a machine readable format, i.e. and therefore is stored as metadata. So we would have effectively the DAP populating a statistical metadata repository, which would take as input and be based on standards metadata, so CDISC standards and measure code lists and things like that, but also corporate standards, and we've also would have trial metadata, so all the study specific metadata that's not specifically the statistical metadata, so the data collection metadata and the like would be required as well. And what I'm putting forward here is that the statistical, specifically the statistical metadata that we populate and capture is in SDMX format. And you'll see towards the bottom of the screen a square box, which I've called iShell, which is the interactive shell application that we would need as well, which can run off the statistical metadata, allow us to create shells, and also do this kind of press a button and spit out the visualizations that displays the tables, figures, and listings. I'm not really going to talk about that in this presentation, but I'm hoping to talk enough about how that might work that it seems credible that we can have one of these. What I am going to focus on is the right-hand side here. How do we take as input the statistical metadata in SDMX format and use that to make ADaM data sets, and do that at a press of a button. So let's take a very brief, and this isn't going to be a tutorial on SDMX, but I think it's worth just making a very short pitch on it. Statistical data and metadata exchange, it's a standard that's been around since 2002, so a couple of decades. It was established and continues to be sponsored by I think 6 or 7 intergovernmental agencies, so the UN, the IMF, OECD, Eurostat, etc. Big organizations that have been around for a long time and frankly will continue to be around for a long time. For the last decade it's been an ISO standard, but the key point is domain neutral. Although it's come from a intergovernment background, it's not an intergovernment statistics standard, it's a domain neutral standard, and a lot of the problems it's solving are a lot of the problems we're solving in a different domain. It is also a very comprehensive standard, and so briefly to kind of touch on some of the things you get in the box, you get an information model which defines the metadata. That's based on a W3C standard, a W3C data cube standard, which is itself based on the W3C semantic web standards, RDF and OWL. And I'd point you to of annotated OWL with the biontology.org, where there's a big list of ontologies for bioanalysis, and I'll touch on some of that. You also get in the SDTMX standard data formats, XML, CSV, JSON, and like. You get a registry, so it defines an interface for a metadata, for an SDTM SDMX metadata repository. So, if you want to avoid vendor lock-in in terms of metadata repositories, that might be a way to go and to use that. You get a REST and a SOAP API. VTL is part of the standard as well, which is a validation transformation language. And of interest there is the c2metadata.org project, which is has VTL running in R and SAS and a range of other languages. Allows you to, again, in an independent, standardized way, define conformance checks and validation checks and things like that. So, key points there: domain neutral, and it's a pretty comprehensive, robust standard. So let's have a drill into DataCube. This is the kind of heart of the metadata. So to define a data cube, you start by defining three things. Everything's a concept. So weight is a concept, blood pressure is a concept. Code lists in the DataCube code list can be hierarchical as well as a linear list, and because it's using the RDF standard, can link to a whole range of predefined code lists you can use as well. And the data formats are the representation of the data. So, and a concept a code list can apply to a concept, and a data format can apply to a code list and that kind of thing. So that's the start. Where does it start? You define concepts, code lists, and data formats using the vocabulary of the code list, SDMX code list vocabulary, and that gets you that defined in a machine readable format. You then use the concepts, code lists, and data formats to define the structure of the data. So there's a data structure definition which defines the measures. So what's the thing we're observing here? The weight of a subject, the height, their blood pressure are the measures. The dimensions are the dimensions of the measure. The way to think about dimensions are the measure by something. So, weight by visit. So visit's a dimension. And attributes are attributes of measures, dimensions. So, for example, a blood pressure might have an attribute unit, which is beats per minute. So, and once you've defined all of that using the DataCube formats, then you've got yourself a DataCube. And this is what I mean by it's domain neutral. It contains all the information in a completely generic form, all the way back to the concept that it's based on. So there's nothing built into the standard. That means that you get all the OLAP type of functions for free, effectively. So you can slice it and dice it in any way you want. You can drill down. You can roll up and apply summary functions. You can pivot the data without having any knowledge of what the contents are. And it's that functionality that you get that can apply to every single data cube. That means that you can create the reporting, the iShell type visualization tools that I was talking about. So great. How do we create a data cube? Let's look at an example. An example I'm going to talk you through is I've just taken this from the CDISC website. There's a document, ADaM examples commonly used in statistical analysis, and this is example 6 on multivariate analysis of variance. So I'm putting this forward as the type of source documentation that we currently use and would give to a programmer for them to spec and program the ADaM dataset. And I guess what I'm saying, and I'm going to try and show you, is how actually this contains all of the metadata that we need to create the cube. So for example, when you read the text, it talks about, okay, this AD mood and ADaM data set, where we're going to analyze the profile of mood forms that are collected at baseline in week 6, the POMs, and we're going to analyze the subscale and total scores. The data is collected using a 5-point Likert scale, which goes 0 to 4. It defines what the subscales are, tension, depression, anger, etc. And it also defines how they are summarized from the Likert data, and it defines what the total score are and how that's calculated from the subscales. So to go back to how does this map onto what we're talking about? So we've already, so in that, let's think about concepts. So multivariate variance is a concept. So we would put that in as a concept we're using here. Profile of mood is a concept that came straight out. The subscale scores, the total scores, etc. We had straight away identified code lists there. So the Likert scale is a code list. Visit, baseline, and week 6 are visits. These are code lists. And remember how I said that so code lists can apply to concepts. So multivariate variance. So if you go and have a look at the bio, the biostats website that I've instantly forgotten the name of, but that I pointed to a couple of slides ago, you'll find the Stato statistics ontology, which is a published ontology, and in it has a definition of multivariate variance, and so as a code list ID MANOVA. So we can use that. SNOMED control terminology defines POMs. The CDISC control terminology defines Likert code lists. Because this is using RDF, these are all can be put in there and used and linked to the cube, and we can define data formats, and you can define in quite a flexible way. For example, you can have ranges, so the -32 to 200 range all goes in. And then we identified a couple of measures. So we're looking to analyze the score on scale and the subscale, but we're also looking to analyze the change from baseline. So there's 2 measures here. Score by subject, score by scale, score by visit. So these are the dimensions: subject, scale, and visit. And because we've got more than one measure in this cube, then we put measure in as a dimension in itself. And then, so an example of attributes that we touched on there were treatment arm is an attribute of subject, and maybe population is an attribute of subject as well. So, so that gives us our cube. How would we then take that and turn that into an ADaM data set? Well, there's 2 key points here to get across. I guess one is that is how we're going to go about doing this, which is effectively by ripping the cube apart and putting it together in a tabular form. And the second one is how do we map? Where do we put the information that we map that gives us the mapping from the cube to the ADaM dataset? So on the first point, how we unwind this is effectively think about this as a big nested do loop, where we're going to slice the cube up every way possible. So for every attribute, for every dimension, for every measure, and write them out in a tabular form. So what I'm trying to show in the bottom right here is that each of the attributes, treatment, so we've got here, we would have treatment and population arm going across the way. Each of the dimensions, so the subject, the scale, the visit, the measure, going across, and then the score. And doing that in a nested do loop unwinds the whole cube. So we end up with something like this, which is the ADaM dataset. So you can see here the attributes, which are on the left. Yeah, so we've got attributes on the left, which are the treatment arm and the population, which are listed out, and then dimensions, although we've got subjects jumping across there, but so we've got the so parameters, got the tension, depression, anger, vigor, etc. Unwinded, and then it's got visits. Let me just jump back so I can make that clear. So we've got subjects, scale, visits, and measure. So the key three ones there are subject, scale, and visit here. So we've got subject, and then scale is mapped to parameter, and then visit is mapped to a visit. And then we've got our measures, and if we come back, we've got two measures. We've got score, and we've got change from baseline, and there's score, which is mapped to eval, and base, which has got change from baseline. So hopefully that makes sense of how that's unwound in that nested do loop. And the second key part to that is, well, how did we know that that dimension is getting mapped to param, and another dimension is getting mapped to a visit? So what the cube has got as part of the standard is this idea of annotations. So you can basically add an annotation to everything and anything, and an annotation is a machine readable data structure that's linked to a part of the cube. And so basically you can use those annotations to contain the mapping to ADaM. So not only is the cube structure in SDMX, but we've also contained the mapping to ADaM in a standard SDMX form as well. So let me try and summarize some of the key points that I'm trying to get across here. I think key points I'm trying to make are one, SDMX. It is not typically and widely used in clinical trials and analysis of clinical trials, but I think there's probably no reason why it shouldn't be. It is a mature, comprehensive standard. It's robust. It's ISO standard. It's sitting on top of W3 open standards. There's a thriving ecosystem around about it. It's backed by large organizations that are going to be around for a long time. It is domain neutral. Is the key thing. It's that domain neutrality that means that you get the OLAP type functionality, operations for free. You get the slicing, dicing, drilling down, pivoting, which means that we can set up the visualization tools that we need to be able to do the visualization and run for example, run the blind reviews before we've generated the ADaM and the TFLs. But it also allows us, as you can see there, to do the transformation to, for example, ADaM and automate that in a standard way. And finally, I mean, it is not without challenges. What we're looking at here would be a different workflow, a different data flow, different tooling, and all the SOPs and training and challenges that come with that. But I do suspect that a lot of that change is going to come anyway. So yeah, I think this is worth considering. So thank you for your time. If you want to contact me and get me on LinkedIn, it's probably the easiest. I'd be delighted to talk about any of this. I've got a repository where some of the data that's getting used for this is on GitHub, and there's some links and background information on SDMX on my blog at metadatadriven.com. So with that, I will thank you and hand back to Chair.